We're going to take a look at graphing linear inequalities in two variables. Our vocabulary: linear inequality in two variables. We have an ordered pair that is a solution of each inequality in the system. So we're going to be looking at a linear equality with the variables, in our case x and y, and we're going to be finding all the ordered pairs that's a solution to the inequality in the system. Now with linear inequalities, we're going to have infinitely many solutions. So keep in mind we're going to have a lot of ordered pairs that we could put, and we'll represent that by just the shaded region. So the solution of inequality, it's going to be the graph of the solutions of the system. So that's what we'll be looking at today. All right, first, just to review some of the some of the types of problems we'll be looking at. We're going to tell whether the ordered pairs 5, -1 and -2, 6 are solutions to the inequality do x plus 3y is greater than 9. So we're going to substitute 5 in for x, -1 in for y. We'll get 2 times 5 plus 3 times -1 is greater than 9. So next step, that will give us 10 minus 3 is greater than 9. And then we get 7 is greater than 9. Now since this is false, 7 is not greater than 9, 5 -1 is not a solution. If it produces a true statement, it will be a solution. So let's test -2, 6. So when we substitute -2 in for x, we have 2 times -2 plus 3 times 6 is greater than 9. And then we have -4 plus 18 is greater than 9. -4 plus 18 will get us positive 14 is greater than 9. This is a true statement. So since 14 is greater than 9, -2, 6 is a solution. And this is going to be important for when we are graphing our linear system. All right. So here we're going to graph the inequality on a coordinate plane. Now one thing when we're graphing inequalities, if you have a greater than sign or a less than sign, our boundary line, the line that we're going to draw off that linear equation, is going to be dashed. If you have a greater than or equal to or a less than or equal to sign, our line, our boundary line, what we draw the coordinate, our equation with, is going to be a solid line. So first we're going to graph this linear line, and since this is a greater than sign and not an equal to, it's going to be graphed with a dashed line. So you're graphing it just as you would the equation y equals -2, but with a dashed line. So when we have y equals a number, it's going to be a horizontal line at that y value. So it's going to be horizontal when y is -2, and once again it's going to be dashed. All right, next, so once we draw our line, our second step, we're going to figure out which side to shade the line on. So keep in mind, the side that we shade, we're either going to shade above this line or below this line, and wherever we shade, it's going to be a solution. So to find that, we're going to do a test point. Now our test point is similar to what we did on 1 and 2. We're going to test a point to see if it's a solution. Typically, we'll be using the test point 0, 0 at the origin. Now you can use any point as long as it does not lie on this line. So we couldn't use -4, -2, we couldn't use 0, -2, we couldn't use 5, -2, but we can use 0, 0 since it's not on our line. So we're going to test this point just like we did with problems 1 and 2 to see if it is a solution. So we're going to substitute 0 in for x and 0 in for y. So for this one, we get y is greater than -2. Now this is a true statement, and we talked about, since it's a true statement, 0, 0 is a solution. So since 0, 0 is a solution, we're going to shade the region that includes 0, 0. So for this inequality, we're going to shade above the boundary line. So everything ordered pair above the boundary line is a solution. So this is our linear inequality solution. Keep on shading, and that will be our solution. Let's take a look at the next one. So we have 5x plus 3y is greater than -9. Now since we have a greater than or equal to, that equal to, we're going to draw that boundary line with a solid line. And we're going to still put it in the form y equals mx plus b. So we're first going to subtract 5x from both sides. So we get 3y is greater than or equal to negative 5x minus 9. And I'm going to divide both sides by 3. So we get y is greater than or equal to negative 5/3 x minus 3. So we're graphing it as the line y equals negative 5/3 x minus 3, and we're going to graph it with a solid line to connect our ordered pairs since we have a greater than or equal to or a less than or equal to inequality sign. So we y-intercept at negative 3, then we can go down 5 units to the right 3, or we can go up 5 units to the left 3. Connect it once again with the solid line. And then we need to move on to our test point. So our test point, once again, I'm going to use 0, 0, but you can use any point as long as it's not on the line. So you could use negative 8, 0, you could use negative 6, negative 6, you could use 0, 7, you could use 9, negative 2. As long as it's on that line, we can use that point. So I'm going to test 0, 0, substitute 0 in for x and 0 in for y. Now from this point, you can either substitute it into the equation that we solved or the original equation. I lean towards putting in the original equation just because it works out nicely, especially with the test point 0, 0, because we're going to get 5 times 0, which is 0, plus 3 times 0, which is 0, is greater than or equal to negative 9. So we get 0 is greater than or equal to negative 9. Now 0 is greater than or equal to negative 9. This is a true statement. So 0, 0 is a solution. So we're going to shade on the side of the line to include 0, 0 in our solution. So we're going to shade to the right of this line. And when we take a look at our shaded region, any ordered pair that's shaded will produce a true statement in our original inequality. Now since this inequality is greater than or equal to any point that lies on the line will also be a solution, because you can think of that as shaded in. Now the one before, our line was dashed, so any point on there would not be a solution. All right, the last problem we're going to take a look at is 4x minus 3y is less than 9. Same thing, we're going to put it in slope-intercept form. So negative 3y is less than negative 4x plus 9. Then we're going to divide both sides by negative 3. And keep in mind, since we're dividing by a negative number, that's going to flip our sign. So this is going to be y is greater than positive 4/3 x minus 3. So we'll start at the origin, go down negative 3, go up 4 over 3, and you could also go down 4, 1, 2, 3, 4, over 3 as well. And this is going to be a dashed line since we have a less than or greater than sign. So we're going to connect our lines with a dashed line. All right, once again, we're going to choose a test point, and keep in mind I'm going to use 0, 0. If your line crosses 0, 0, you'll have to use a different one. But since none of our lines have so far, we can use 0, 0. And I'm going to substitute it once again in the original equation. So I'll get 0 minus 0, which is 0, is less than 9. So 0 is less than 9. This is a true statement. So 0, 0 is a solution. So we want to shade to include that solution as 0, 0. So we're going to be shading to the left of this line. And once again, any ordered pair that's shaded will produce a true statement to our original inequality. So negative 8, 0, negative 6, 9, all of those will produce a true inequality. All right, hope you have a great evening, and I will see you tomorrow.